Hi, in this episode, we shall be looking at the proposed memorandum for the Grade 10 Mathematics paper to June examinations 2025. Okay, so this paper was out of 75 marks. Instructions are clear. We have 6 questions that we have to work on. Okay, question number 1. Okay, 1.1. They're telling us that in the diagram below, P is this much, Q is that, R is XY. And then we have theta for P. The first question, 1.1, they want us to find the distance PQ. So we know that for us to get the distance, we must use the distance formula. That simply tells us that x1 minus x2 squared plus y1 minus y2 squared. Now, since we're focusing on PQ, if I call this my x1, y1, then this is going to be x2 and then y2. Let's substitute that. So it's going to be 5 minus 1 squared plus negative 2 minus 1 squared. Everything is under the root sign. Okay, so when I punch this into the calculator, I'll have that. Then I'll have that, which gives me just 5 units. Okay, so that is 5 units for the distance of PQ. Then 1.2. Can we find the gradient of PQ? So gradient of PQ will be the change in y over the change in x. So I can still do the same thing, or y2 minus y1 over x2 minus x1. When I substitute, it's going to be 1 minus minus 2 over 1 minus 5. That gives me a 3 over negative 4, meaning that our gradient is just negative 3 over 4. Okay, then 1.3, I'll put it aside. They're telling us that it's further given that this angle Q is a 19. Okay, so if Q is a 19, they want us to get the size or the value of X for 5 marks. Now, one thing we need to do, or one approach we can use, is use the gradients. Okay, meaning that the gradient of PQ times the gradient of QR, it must give us negative 1, since the lines are perpendicular. Okay. Now, we know that the gradient of PQ is negative 3 over 4. Now, I'm multiplying it by the gradient of QR. So I have to do y2, y1 next, and all of that. So it's going to be 1 minus 7 over 1 minus x. This should give us a negative 1. Then we can divide both sides by this negative 3 over 4, meaning that we're going to have 8 over 1 minus x. Should give us just a 4 over 3. We can cross multiply. Okay, so that's going to be 24 is equal to 4 minus 4x. Let's move the 4 that side. We're going to be left with a 20 is equal to negative 4x. Divide both sides by negative 4, meaning that our x becomes a negative 5. So that is the only thing that we had to do for us to get those 5 marks, okay? We said just cross multiply. Okay, so meaning that x is a negative 5. All right, then 1.4, if x is negative 5, so they are confirming it. Can we get the coordinates of the midpoint of PQ? So if this is PQ, we know that midpoint is given as x1 plus x2 divided by 2. y1 plus y2 divided by 2. So let's do the substitution. So our x1 is a 5 plus the x2, which is a 1 over 2. Our y1 is negative 2 plus 1 divided by 2. Okay, so when we simplify this, we know that 5 plus 1 is 6 over 2, which is a 3. This negative 1 over 2. So this becomes our midpoint. So we're saying that this midpoint is somewhere here with 3 and negative a half. Okay, then we proceed. They're telling us that 1.4.2, we must get the coordinates of vertex T such that a quadrilateral formed by joining T with the vertices of the existing triangle will be a parallelogram. Now, since we are being given this midpoint here, chances are high, okay, since the question is not telling us where the T is. So I'll try to look at all the possible explanations, okay? So chances are high we can extend this and have a T somewhere here, okay? But also, we could also extend this to that and then have a T somewhere there, okay? Alternatively, you could also push this into that direction and then have a T somewhere there. So in other words, we have three options of having the T. Now with the first option, I'll take this because it is quicker. So if I use the midpoint, we know that the midpoints will be the same for a parallelogram, okay? So if our x is a -5 there, okay, so I'm using midpoint, we're saying -5, -5 and -7. Our midpoint, we said is a 3 and -1/2. Now we are finding T, which is xy. Okay, so that's the kind of approach that we're looking at. Then when I use the midpoint formula, it's going to be x plus -5 over 2 must give me a 3. Cross multiply, x minus 5 gives me a 6. Move the 5, which means x is 11. When I try with the y plus -7 divided by 2 must give me this midpoint coordinate, which is -1/2, meaning that y minus 7 is -1. Move this y that side, meaning that the y is going to be a 6. Okay, so chances are high that t can be 11 and 6. Then option 2, we're saying what if the t is somewhere here in this quadrant, meaning that we need to find the midpoint of PQ. And with the midpoint of PQ is going to be 5 and -5 divided by 2, which is going to be a 0. And then -7 plus -2 divided by 2, that's going to give us a -9 over 2. So this is our midpoint, okay? And then I'll just connect it with this QT, something like that. So I'm looking at another approach again where we have xy. The midpoint we said is 0, -9 over 2. And then our q was a 1 and 1. Okay, so let's do the midpoint formula. So this is going to be x plus 1 over 2 must give us a 0, meaning that our x is -1. Then y plus 1 over 2 must give us a -9 over 2. Cross the 2's out. 9 plus 1 is a -9 when we move the one that side, which means that y becomes -10. So chances are high that even t can also be -1 and -10. Okay, so that is what we are having. Then we just left with one approach, okay, one other option that we can look at, okay, where it is in that other quadrant. Okay, let's also look at it. So if T is in this quadrant here, okay, if I'm focusing on that T, meaning that RQ is going to be a midpoint. So if I look for the coordinates of the midpoint, I'll be focusing on -5 and 1, which is -4 divided by 2, which becomes a -2. A -7 and that is a -6 divided by 2 is a -3. Okay, so we're saying T, which is xy, our midpoint, which is going to be -2, -3. And then we're going to be using point P, which is 5, -2. Okay, so it's going to be x plus 5 divided by 2 must give us a -2. Cross multiply or multiply both sides by 2, meaning that x is going to be a -9. And then y plus negative 2 divided by 2 must give us a negative 3. Cross multiply y minus 2 gives us a negative 6. If we move this one that side, meaning that our y is a negative 4. So it's still possible for t to be a negative 9 and a negative 4. So if that is true, these are the various options that we can have, okay? So depending on how the examiners are going to treat this question, but those are the options that we would have had for that particular question. And then they want us to get the value of theta, okay? So now for us to get the theta, we have the distance PQ. Okay, let me just try to, no, let me use a different color. So we said PQ, okay, this one was 5 units. Then what we need, we can either find the distance PR or you can find the distance QR, and then we use the trig ratios since this is a 19, okay? So let me find QR so that I use tan. So we're saying the distance QR, we're focusing on 1 and 1, and then negative 5 and negative 7. So with the distance formula, it's going to be 1 minus minus 5 squared plus 1 minus minus 7 squared. So that becomes 6 squared is a 36, and then 8 squared. So 8 squared plus 6 squared, meaning that our QR is going to be 10 units. Then we know that if this is the opposite, this is the adjacent. The trig ratio that combines opposite and adjacent is the tan. So I'll say that the tan of theta is equal to the opposite, which is 10, over the adjacent, which is 5. So meaning that the tan of theta is a 2. So theta will be the shift tan of 2. Okay, so shift tan of 2. Let's see what we get. We are getting 63.43 degrees. Okay, so that is how we would have answered question number 1 for 22 marks. All right, question number 2. If theta is 207.25, beta is 63.75, we must find this to 2 decimals. So with this, just do the substitution, okay? Our theta is a 207.25. We are subtracting 63.75. You don't need to even simplify what is inside the brackets. Just substitute the way it is, okay? So 207.25, we are subtracting 63.75. Okay, the answer I'm getting is a negative 0.80, okay? Then I know that cot is also the reciprocal of tan. Okay, so I can say 1 over tan, meaning that I'm going to have 1 over the tan of the beta, which is 63.75, okay, plus the theta, which is 207.25. Everything is divided by 3. So punch the whole thing the way it is in the calculator. So 1 over, we're saying the tan of, we'll use the fraction, 63.75, 207.25 divided by 3. This is 207. Okay, so the answer that I'm getting is very weird, né? Like it's the weirdest answer. So my answer is negative 0.01. That's if I'm rounding off to decimal places as the question wanted. So I don't know, you can tell me what you have on your side, okay? Let's see, 2.2.1, determine the value of x correct to decimals. We are solving trig equations, okay? So if we have this, let me put it this side. I'm saying this is 2.2.1. So 2 sine x minus a quarter is equal to 1. So our step number 1 is to eliminate whatever is around the sine x to the other side, okay? So move the quarter that side, meaning that 2 sine x is going to be 1 plus a quarter, okay? So 1 plus a quarter gives us 5 over 4. And then we're going to divide both sides by 2, meaning that the sine x is going to be 5/8. So for us to get the x, we must press the shift of sine and then 5/8. Then let's see what we have. So shift sine, we're saying 5/8, which gives us a 38,68 degrees. Okay, so that is 2.2.1. Let's look at 2.2.2. They're telling us 9 sec 2x. It must give us a 13. Okay, so step number 1, we just need to get rid of whatever is around the sec, meaning that the sec 2x is going to be the same as 13/9. So divide both sides by 9 here. No? But we know that the sec is the reciprocal of cos. Okay, so our 1/cos 2x should give us 13/9. But the easiest way to do this is for you to just say that cos 2x is the same as 9/13. You can just switch it directly. Because here, if you cross multiply again, you will be moving in circles, but you'll end up with that same kind of ratio. Then we're going to say 2x is equal to the shift cos of 9/13. Okay, so when I use shift cos of 9/13, it gives me a 46,19. It's 186, but I'll say 19. Then I'll divide this by 2, meaning that my answer is going to be a 23,09. Okay, so that is what I would have obtained for 2.2.2. Then 2.2.3. 2.2.3. Okay. They're telling us that the tan of theta minus 20, okay, plus 1 should give us 1,43. So what we need to do, eliminate anything that is around the tan. So move this on that side, meaning that the tan of theta minus 20 is equal to 0,43. And then we do the same thing. Theta minus 20 should give us the shift tan of 0,43. So theta minus 20 is equivalent to, we said shift tan of 0,43, which is a 23,27. Let's move the 20 that side. It's going to change the sign to a plus, meaning that our theta is going to be 23,27 plus a 20, which is a 43,27 degrees. All right, so that is what we were meant to do for question number 2. All right, then question number 3, refer to the sketch and the statement below to answer the questions that follow. So whenever we are given this, okay, one thing we need to do with the Cartesian plane is that you have to complete this and create a triangle. So we know that this 12 represents the horizontal distance, and then this 9 represents the vertical distance. So if P is this, the Cartesian plane, X OP is theta, determine without the calculator the length of OP. So here we're going to use the theorem of Pythagoras. So meaning that our 2.1.1, we're going to say that our OP squared is going to be 12 squared plus 9 squared. We're looking for the longest side, so we have to plus. And then our OP is going to be the square root of 144 plus 81. Okay, so 144 plus 81 gives me 225, and the square root of that is 15 units. So meaning that this is a 15. Now, if our triangle is complete, then we can go ahead and answer whatever questions that have been posed to us. Now, they want the cosec of theta. Now, we know that cosec is the reciprocal of sine, okay? And sine is opposite over hypotenuse, meaning that the cosec of theta should be the hypotenuse over the adjacent. So our hypotenuse is 15. Our opposite is a 9. Then if there's anything common here, we need to simplify it. So by 3, which means it's going to be a 5/9. 3. We just leave the answer like this. We are not allowed to change it to decimals, otherwise we shall notice that you use the calculator, okay? Then 2.1.3, we must simplify this, so it's going to be 4 times the cos. We know that cos from our SOHCAHTOA, okay? Cos is adjacent over hypotenuse, meaning that it's a 12 over 15, but we are squaring this. Plus, this is 4, the sign is opposite over hypotenuse, so 9 over 15, but this one must also be squared. Then we know that 12 squared is 144 times 4, okay? So 144 times 4 is giving me 576 over 225. Plus, here we can use a calculator, okay? That's going to be 81 multiplied by 4. Okay, so we're saying 81 times 4 is a 324. Divide by 225. Now, we're seeing that the denominators are just the same. We just have to plus the top numbers, okay? So 576 plus 324, I'm getting 900, okay, over 225. So 900 divided by 225, the answer is just a 4. So that is how we were supposed to answer this particular question. And then 2.1.4, square root of 1 plus cot squared. So cot is the reciprocal of tan, and we know that tan is opposite over adjacent, meaning that our cot is going to be the adjacent over the opposite. So I'll say that square root of 1 plus the adjacent is 12 over the opposite, which is 9. And then we square this. Please put that in the calculator and we see. So 1 plus, we're saying 1 plus, I'll say 144 over 81. That gives me a 25 over 9. But then we're finding the square root. Square root of 25 is 5, square root of 9 is 3. So that becomes our final answer. And then 2.2. They want us to still use the diagram and the information to prove that the tan theta is given as this. So this is an identity, okay? So start by your left-hand side. What is the tan of theta? We said it's the opposite over the adjacent. So it's going to be 9 over 12. Okay, so if that is 9 over 12, divide by 3, which is going to be 3 over 4. Then on your right-hand side, let's look for the sine of theta. We said opposite over hypotenuse, which is a 9 over 15, okay? So 9 over 15, you're dividing it by the cos, which is going to be 12 over 15. Remember, we do not, remember this question does not limit us on whether to use a calculator or not. You can even use a calculator here. So it's going to be 9 over 15 times 15 over 12. This 15 cancels that. We know that 9 over 12 is the same as 3 over 4. So it's the same thing, 9 over 12. So therefore, the tan of theta is the same as sine theta over cos of theta. So that is the end of question number 2, but it's not making sense. I mean, they say question 3 and then the numbering is 2, like what's going on? Okay, let's not mind them. Let's look at question 4. So simplify without using a calculator. Sine of 45, cos squared of 60, cos of 45. So these are what we call the special angles. So from our special angles, we know that the sine of 45 must be 1 over square root of 2. And then the cos of 60 is just a half, okay? But then we have to square this. Over the cos of 45 is 1 over square root of 2. Now someone will wonder, where is all this coming from? So if we have this sort of triangle, 1 and 1, and then you find your Pythagoras, this will be square root of 2. So if that is a 45, and then that is a 45, that's how we get the 1 over root 2 over 1 over root 2. The other one is the triangle of 60, the equilateral one, okay? Whereby that's a 2, 1 and 1, then that is a root 3, that is a 60. So adjacent over hypotenuse is the cos. Okay, so this is going to cancel that, meaning that we have 1 over 2 squared, which means our answer is 1 over 4. So you'll get a mark for each substitution and probably the final answer. 4.2. Determine the value of theta without using a calculator. So I'll put it this side and say it's 4.2. So they're telling us that the cosec of theta minus 1, okay, is equal to 5. Remember the rule, take everything to the other side, leave the ratio on its own. So it's going to be the cosec of theta is equal to 6. When you take this one, this side it will be a plus. Divide both sides by 3. Cosec of theta becomes a 2. Okay, but we know that cosec is the reciprocal of sine. Okay, so it's as good as me saying that the sine of theta, and then I change this ratio around, and I'll say it's 1 over 2. And then I'll have to find the theta by simply using the shift sign over half. And then my answer becomes a 30. Okay, shift sign is a 30. We know that the sine of 30 gives us a half, even from our special angles. Alternatively, 1 over sine of theta is equal to 2 over 1. You cross multiply, 1 is equal to 2 sine theta, and then you divide by 2, you still end up with the same result. Okay, question number 5. Consider the square ABCD with diagonals AC and BD intersecting at E. 5.1. A square can be described as a rectangle with equal sides. Can you list 3 properties of a rectangle? So one thing we know about a rectangle is that 1, the opposite sides, okay, opposite sides are equal. In other words, we can say that 2 pairs, we should just make it a little bit advanced, not this grade 6 kind of approach. We can say that we have 2 pairs of opposite sides that are equal. Okay, because we know that a rectangle is something like that. This is equal to that, this is equal to that. Okay, so this one pair, and then that's the other pair. And then number 2, we know that 2 pairs of opposite sides will be parallel. Okay, meaning that they do not meet each other. And then lastly, we can talk about the diagonals, okay? So diagonals bisect. Diagonals bisect, meaning that they meet at a point and then everything becomes equal. So this is the same as that. This is the same as that. So those are the 3 properties we can look at, okay? Someone could also talk about the interior angles and all of that. There's no problem. 5.2, use the given square ABCD to show that the diagonals of a square bisect at right angles. Now, if I'm using, now let me put the square this side. This is 4 point, that's 5.2. Okay, please let's pretend like that is our square. Let's pretend that that is our square. Okay, so we know that all of this is that. They labeled it as A, B, C, D, 1, 2, 1, 2, 1, 2, probably 1, 2, no, 1, 2. This is a 1, this is a 2. And then this is a 1, that is a 2. Okay, so it's A, B, C, D. Okay, so how do we prove that this is a 90? So in this case, prove that the diagonals bisect at right angles. Okay, so the only thing we have to prove is that there is a 90 there, there's a 90, there's a 90, or there's a 90 there. Okay, now, the only thing we have to do is that we know that this entire angle is a 90. We can start with that. And if it's a 90, we know that the diagonals do bisect the angles, okay? So start by telling us that D1 is going to be a 45, and then D2 is also going to be a 45. So if that is true, that that's a 45 and that's a 45, go ahead and tell us that that angle is also a 45. So A2 is 45. That's because those are angles that are opposite equal sides. Okay. Now, we need to find that missing side or missing angle, which is going to be AED. So AED plus the 45 plus the 45 must give us 180. Those are angles in a triangle. Okay. And if that is true, we know that AED should be 180 minus 90, which gives us a 90 degree. Now that is about the angle, okay? Now about the bisecting of the sides, we can use this triangle as well as this triangle. Or you could use the triangle and then this triangle down here, and then try to show us that these two triangles are congruent. So if I focus on this one and this one, I know that A1 is going to be the same as C2. Okay, so we're saying that A1 is the same as C2. Those are alternate angles. Those are alternate angles because AB is parallel to CD. Then we know that B1 must be the same as D2. B1 must be the same as D2. Still the same reason. Alternate angles because BC is parallel to AD. Now, it simply leaves us with this angle here and this angle, which will be the same because these are vertically opposite. So I'll say AEB. Okay, AEB is the same as CED. CED, vert op. Therefore, the triangle AEB, triangle AEB is congruent to triangle CED because we focused on the angles. No? And this implies that the diagonals do bisect, meaning that BE is the same as ED. Okay, BE is the same as ED. And then we know that AE is the same as AC. AE is the same as EC. So that is what we had to do for that particular question to get the 7 marks. Okay, question number 6, which is the last question. They're telling us that given the diagram below, we have a rhombus, D2 is 33,63. Then with reasons, can we determine the value of D1? So D1 must also be a 33,63. Reason is going to be diagonals of a rhombus, okay, because the diagonals do bisect these angles. So it's a 33,63. And then they want us to get DCB, this entire angle. Now we know that with a rhombus that these two will be parallel. So, but we know that D and C form what we call the co-interior angles. Co-interior angles must be equal to 180. So we shall say AD is parallel to CB. Then if I'm looking for C, it's going to be 180 minus 2 times the 33,63. And I punch this into the calculator. I'm saying 180 minus twice of 33,63. That gives me 112,74 degrees. Okay, so 112,74 degrees. Then it is further given that OE is parallel to BC. So this is parallel to that one. Okay, I don't know if you're seeing something. that I'm seeing, especially with this triangle here. Remember, this is a midpoint. The lines are parallel, so which means even E must be a midpoint there. So DC is a 20. So if that's a 20, they want us to get the length of OC. So if that's a 20, we can find, we know that this is a 90. We can find OC. But how is that going to be done? How are we going to do that? So you can use the trig ratios, okay? As much as it doesn't look proper for me to find it that way. Okay, because this is our hypotenuse. And then we have this angle already. We're looking for the opposite. Okay, so let's say we have we're looking for the opposite, we have the hypotenuse. So we're gonna use the sine. So we shall say that the sine, okay, the sine of 33,63 should give us the opposite, which is OC over 20, meaning OC is 20, sine of 33,63. I don't know why they brought this question in term 2, but it's fine. Let's see, 33,63. So that gives me 11,08. So 11,08 centimeters. And then they want us to get the length of OE, this distance. So step number 1, start by telling us that CB is also going to be a 20. That is basically sides of a rhombus. Those sides must be equal, okay? Then if this is a 20, then OE must be a half of the 20 because of the midpoint theorem. So OE is going to be a half times 20, which is 10. Reason is going to be the midpoint theorem. All right, guys. So that brings us to the end of this paper. Okay, so besides the 7-mark question and just 1 or 2 other questions, I feel like the paper was fair enough. Okay, so guys, I wish you all the best in all that you're doing and your remaining examinations. I sign out. Bye-bye.